designed yet, but we've got the core function done. So what this is, it's going to be a machine that's going to automatically cut up lengths of cable. That cable is going to be sort of 4 to 5 millimeters in diameter, and we'll have a means to punch in how many lengths we want cut off a roll. But I'm not going to have a keypad where I enter the length. Instead, what I'm going to do is it's going to be a system where a user grabs the cable, pulls it out of the machine until they get the length that they want. Once they get the length, hit a button, immediately the machine is going to cut that cable and then continue to feed the cable out the same length that the person pulled out, and then cut and then repeat until the required amount is reached. We designed this about probably 2 months ago. Some of it's sort of left my mind, to be honest, but was sort of slowly getting back into it. I'll mainly be working on this display section. Yeah, as you can see, it's getting a little bit horrendous here, but I sort of got too deep into it to back out of it. I decided to just keep going. This is going to be for internal use, a tool for an internal use. It's not going to be sold to anybody or resold to anybody. So yeah, it doesn't need to look pretty, it just needs to work. Anyone into electronics will see that, will probably quickly see that we're using some old school electronic techniques here. I've decided not to use microprocessors. I'm just not geared up for that sort of thing at the moment. And as you can see, I haven't drawn up a proper circuit board. What you're looking at here is a Vera board. I'm certain the machine's going to go, so I've committed to soldering everything as opposed to using this stuff. This stuff is quite expensive for prototyping and testing things, but anyway, it's been some years since I've done this sort of stuff. There was a time in the 80s and 90s where I'd done this sort of stuff quite often. Yeah, no microprocessors, and I'm not going to use stepper motors. The reason being, I've seen such machines, commercial machines used in the past a couple of times, and what I've always seen is the drive mechanism that pushes the cable out. I've often seen those slip and the cable is not coming out at the length that the machine thinks it's come out. So I've decided, while I could still use a stepper motor, I've decided to just use whatever motor that I find, and I'll ramp the speed up when it starts until it reaches a steady speed, and then as it comes to the end, I'll ramp the speed down until it stops, and then I can cut the wires. So basically, the drive circuit that drives the cable out is going to be completely independent of the other circuit that's measuring what's being driven out. So even if the drive mechanism slips, it's not going to matter, because it's just going to keep going until the independent measuring device reaches the length that has been pushed out. So anyway, that's what I've decided. I'm hoping tomorrow I can start testing that I've got all this display and everything hooked up. I mean, she's pretty full on behind here. I could easily miss something, but I'll test stage by stage. Right now I'm just working out the connections from this chip to that chip and how much space we're going to use here, so that I can determine where this is going to be, and that'll be repeated that way. Once I get that done, we'll have the logic done for the top counter, and then I can replicate that here for the bottom counter. When the person pulls out the cable, this number's going to climb upwards until they stop pulling it. Once they hit the button, that number is going to get jammed to this display here, and then it'll then fire up the motor, which will then push the cable out. Once that starts happening, the encoder will start spinning, clocking this display here, and start decrementing the number all the way down to 0. Once it gets to 0, we'll know that you've got a replicated amount of cable that's been pushed out that the person pulled. And then once that gets to 0, it'll cut the cable, and basically just keep repeating that until we've got until we've reached a certain count. Now, as I say, I haven't designed the counting portion of the circuit yet, but we'll get there. Tomorrow I hope to test some of this display circuitry, make sure I haven't got any shorts and bridges and things wired wrong, so I need to, fire up the circuit and make sure the correct segments turn on each of these displays. These LEDs will be a binary representation of the decimal number above. So yeah, it's gonna come down to maybe here. I could have compacted all this and removed a lot of this wiring had I put some of the chips on the other side here, but I wanted the displays right there and at the top of the board, so we're just going to have to go with what I've got. But as I say, it just has to work. Number one, it doesn't need to look pretty.